Good morning and welcome to our second webinar of the day. It is Distribution Situational Awareness provides improved system reliability and member satisfaction. It is with Aclara at Brownstown. The presentation will roughly last about 45 minutes. We'll leave about the last 15 minutes for Q&A. So please submit your questions using the chat function. Direct those at AIC and we will read those as they come in to hopefully provide a little bit back and forth. We have muted all the microphones, so please keep those muted to eliminate any background noise and items. With that, we have three different presenters, so I'll go through their bios real quick. We have Gary Moody. He is currently a sales director for Aclara, serving the central region of the U.S., including Illinois. He has over 25 years of experience in the utility sector as an executive, leading his direct sales team and various channels to market to win in the competitive world of smart grid. We have David Maloney. He is a senior application engineer in the Aclara Grid Monitoring Business Unit. For over 20 years, he has been helping customers adopt and leverage new technology platforms in both the telecommunications and electric utility sectors. And finally, we have John Mars. He is an outside sales rep for the technical sales division of Brownstown Electric Supply Company. John covers a 4-state area for Brownstown, which includes Illinois, Southern Indiana, Kentucky, and Southern Ohio. John has 14 years experience in the electric utility industry. And with that, I will hand it over to Gary.
Thanks, Brian. Thank you, Ashley. I hope everybody can hear me clearly. Happy Tuesday. And we are very, very excited to share a technology with you that'll help your utility improve your system reliability and your member satisfaction. So with that introductory slide, I will be introducing the team. First of all, John Mars. John, you want to say hello to everybody?
Yeah, hey everyone, thanks for attending. We appreciate the opportunity to present this technology to you. As Brian said, I cover the technical sales for Brownstown. We deal with everything from metering to capacitor banks to power grid sensing, and then we provide all the technical support with software controls and everything else. Appreciate everybody's time today, and Gary, I'll let you take off with it.
Thanks very much, John. And I do have a couple teammates on the phone with me. You're going to hear from one of them, Dave Maloney. Dave, you want to unmute and say hi to everybody?
Yeah, hi everybody. This is Dave Maloney. I'm with the Aclara side as well as Gary. Appreciative of the opportunity to take this time to present our grid monitoring solution to you guys. I am the senior application engineer over the grid monitoring product. So happy to be with you guys and to answer any questions that we can throughout the presentation.
Thanks, Dave. And again, you'll be hearing from Dave as we go through the presentation. We do have another teammate on, a relatively new hire, but very experienced in the industry, Mr. Jeff McCaman. He is muted with the rest of the participants, and Aclara is, in these tough times, it seems we still are able to hire some new people and continue to grow our company. I did not really put together a huge here's Aclara sign, but what you need to know is Aclara was purchased by Hubble, not the telescope people, but about 2.5 years ago, February, two and a half years. It's been a great thing for me personally. The benefits got better, and my credit card changed. Everything else is the same. So it's been a very, very nice purchase. Hubble's reputation in the industry is to grow both organically and, of course, by acquisition. And normally when they purchase a company, they sort of leave the companies alone, let them do their thing. The same is held true with Aclara. However, I will say that they seem to pluck our CEO and put him now in charge of all of Hubble's utility services division. So Hubble is broken into 4 categories. One of the major ones is the utility category, and our CEO president is now running that entire group. So We're well represented within Hubble and very excited to be part of a $4.5 billion financially stable, robust company. So enough of the commercial about why Brownstown and Aclara are amazing, and on to the presentation. First of all, we are going to talk about your needs as far as we understand how much member and customer satisfaction are. We're going to talk about distribution reliability and what we can do to help you monitor it and show you what's going on. We're going to talk about the products to do that, how easy they are to install and how safely they are to be able to be installed, along with, of course, everything in our world runs on software. So we got to touch on the software, and not just the software that really makes all the bits and bytes and data and events out there come to life, but also how do we get some of that information into the rest of your utility back office to make better decisions. Finally, we're going to talk about all the different applications and all the different scenarios that this solution will present to you. Some really cool, fun things I think you'll find quite amazing that an electronic sensor with some artificial intelligence applied against some waveform can give you an idea of what's going on. And then finally, of course, questions and answers. We did talk with Ashley and Brian prior, and we encourage you to let them know, chat with them if there's a question come up, if there's anything you need, and they will interrupt us, and we will be glad for it. We'll be happy to have this as interactive as possible. So with that brief agenda, we wanted to talk about how we know your needs. So there's been a lot of studies done. A lot of the utilities have mission statements out there. We've looked at them, we've studied them, we've put them in our CRM. We know how important your employee safety is. We know how important your customer/member satisfaction is. And we know this really does come back to system reliability, being able to provide reliable power continuously. And so with that in mind, JD Power and Associates did a study, and you are probably all familiar with this study, and they've put all the top priorities as far as what a utility is interested in: power quality, reliability, being a good corporate citizen. Obviously, you got to be competitively priced. How do you communicate to your customers? And when the customer calls, how do you respond? So we understand that background, and with that in mind, we did put together a solution for your distribution substations, and gives you all kinds of cool information at a very competitive price. So, for example, how are you going to know if the substation has some faults going on? How are you going to know if the trees are brushing up against your feeders and your lines without, prior to hopefully a permanent or a temporary outage? Many of you have SCADA, and SCADA is fantastic. And it does give you some really good information when it comes to temporary and permanent outages. In fact, there's been a number of studies done, and SCADA itself will present about 16% of the story, all of the permanent and all the temporary outages. However, there are about 84% of line disturbances that are simply not captured under those two categories. And this solution that we're talking about will give you insights into the other 84% of what's going on out there with your system, and how to keep your system more reliable and robust. So the system itself gets installed obviously on the feeders. We're going to talk about the installation in a bit, but it's used in sort of 5 huge big applications: distribution generation, asset management, interconnect monitoring, wildfire mitigation. I'm not sure how much wildfires count in Illinois, but in California, it's big, let me tell you. And then, of course, reliability and power quality. There's a picture of our sensor here for you to see. There's 2 versions. We're going to talk about them in a minute. Here's a typical layout, and from the transmissions and the substations, and these bad boys just clamp right onto the feeder. The product itself has been around many years. Dave, how long have these sensors been out there, Dave?
The power sensors have been out there almost 7 years now, and the MV sensors that you'll go into here shortly have been around almost pushing 11 to 12 years. Yeah,
over a decade. Very good. Many thousands and thousands of sensors in the field. None of this is going to be, hey, you're the beta customer, we have some cool idea. You are going to be leveraging technology that's been out there a long, long time. And we have many, many happy, satisfied customers that are more than pleased to talk about their solution. One of the customers that has been utilizing this solution to save millions of dollars is Detroit Edison, or DTE Energy. I live in the Michigan area, and for me, I know it's DT Energy. I know they changed their name, but to me, it's always going to be Detroit Edison. But anyway, so DT Energy, they have, I don't know, between 12 and 14,000 sensors out there, which sounds kind of neat. Wouldn't it be great to have thousands and thousands of sensors? And you're thinking, yeah, but my little utility, yes, I understand that we would. Well, let me check with John. John, if one of these utilities in Illinois wants to buy 1,000 sensors from Brownstown, would you sell them 1,000? Is that something you'd do?
Absolutely.
Okay, there you go. In reality, we understand that your solution is much more reasonable. Your municipals, your cooperatives, primarily cooperatives, and we're looking for 3, 6, 9. John has a special on a 12-pack right now with some software, very competitively priced. This isn't a sales pitch. I'm just here to tell you that we understand that you will not be a customer purchasing thousands, and that's totally fine. Your neighboring state, Indiana, this solution has taken off like crazy. Many cooperatives have put in 12, 6, 3. They move 3 around, do some different testing on different feeders. And we're more than happy, pleased, excited to work with you as you start down the path of getting more and more feeder and line information into your system. Here's a another utility in California that has used our solution to improve their CADI. Now, for those of you that know Katie, Mayfie, Sadie, all the sisters, I can't remember all of them, but just make a quick note that we do help improve your CADI. And for those of you that need a bit of a reminder, CADI stands for the Consumer Average Interruption Duration Index. And it basically tracks your sustained interruptions over a total year. And I don't think we're measured against CADIs and stuff, but many utilities like to know this and to be better, and they're tracking it, if not officially and informally. And we definitely help improve your CADI rankings and information and reports, and we get all that information over to you. A lot of times you will just buy 3 of these sensors, pop them up, and have it talk to the software and just start trying to understand what's going on. And a little pilot like that is very inexpensive, very quick, and many of our customers will find tons of things happening that they had no idea were going on. So here's a customer that when you put in some evaluation units, they have all kinds of statistics as far as they were able to better plan patrols. They were able to do better remote switching. They were able to take all this data, combine it with other data, make better decisions. So there's a fair amount of information and analysis available to you as far as helping you leverage these sensors in the field. So what do these sensors look like? We have 2 versions. This is a medium voltage sensor. It hot sticks on, or you can put on your gloves and clamp it on with your hands. If you were with me in Puerto Rico when we were putting some of these on, you would be afraid of how they do it down there. We installed 12 sensors in about 90 minutes, and that included all the drive time and setting up the trucks and literally cutting across the traffic lanes. It was a wild time. Anyway, here's our medium voltage sensor, and it gives you current, fault current, some sags and swells, some power factor. However, its big brother is called the power sensor, and frankly, this is the one that most everybody is putting in. You do have a reference to ground or neutral there through the power resistor, and this will give you the same as the MV sensor plus voltage with 0.5% accuracy, plus real power, plus load flow direction, plus power quality with harmonics and sags and swells and waveforms and power factor. And this is the primary sensor that John has been selling to most all of his customers. As far as what does it do or replace, it replaces a fault current indicator. So it is much more significant as far as data goes than an FCI. Also an FCI, once it goes, you sort of have to drive down the lanes with your binoculars looking for flags and flashing lights. These sensors have communications in them, either Wi-Fi or cellular, and it will blast back to you. In fact, if you have multiple sensors on each feeder, it will tell you, it will geolocate the fault for you. So the crew just drives straight out to where they know the fault has been geolocated. So obviously it has a meter, we talked about that already, GPS locations, load loggers, phase IDs, tons and tons of sensing equipment, gathering all of the data, sending all the data back across that communication path, again, Wi-Fi, fiber if you have the fiber, and cellular. Once we get the data back, we'll talk about what we do on the software, but I just wanted to camp just a few minutes on the installation of these sensors, because one of the best features that this sensor has is how safely, quickly it's installed. I know, Dave, we had talked about you starting the next slide, but if you could unmute, Dave, and just talk about the installation a little bit. You've got a lot more experience installing these, and when I'm talking to the team, I want them to get the most information from the person who knows the most about it. So we'll start one slide early, surprise. And if you could start off with software installation, and we'll go on to the software.
Yeah, no worries at all. So like Gary had said, I mean, the biggest clout we get for these sensors is their ease of installation. And based on the two different designs that he had reviewed earlier, you know, the MV sensor, which is basically our current only sensor, and then its big brother, the power sensor, which gives you the suite of all the power measurements based on the reference to ground. You'll see on that picture, it adds that resistor. So 170K resistor that ties into the neutral. So to be honest, the installation of just the MV sensors, like he's shown, a 15-minute per set, is quite simple to achieve. You set the truck, you put the sensor on the end of a hot stick or glove, whatever your preference is, and you connect that to the hot stick clamp, and you connect to the sensor and just tighten down the clamp. So the clamp actually goes in a two-stage format. So you'll see when you looked at the sensor previously, you'll notice that it has a larger channel in the center, and you're wondering to yourself, well, how could that channel fill a small size conductor or even a larger size? So for instance, putting it on, you know, a piece of 2-aught, when that sensor, the two halves of the sensor close down onto the conductor and the two halves meet together, there's a second stage clamp mechanism inside that sensor body that once that hotline clamp or our eye bolt is twisted, it will continue to pull down that second stage clamp around the conductor and secure it from sliding on the conductor. So that's kind of how we're connecting metallically to the actual conductor itself. The same thing happens exactly with the power sensor. So the same style clamp, two-stage clamp that will connect onto the conductor and secure it from sliding from end to end. And also, the important thing to know with the if you have any instances where you have like a Hendrix type cable or a insulated cable in the field, the MV sensor will still operate on a coated cable. There's no need to remove that and have a bare metallic connection. So we'll still be able to power the CT and generate power from that to operate the sensor. And then also on the MV or the power sensor, in that case, you would require to scrape that insulator back to make a metallic bare connection. So the clamp has a physical connection to the metallic conductor, and therefore giving us that path to the neutral or to ground from the bottom of the resistor. Okay, Gary. Okay, so we kind of just went through, there's two main pieces of the SMS and Aclara grid monitoring solution. The first being the sensors, which we just kind of briefly touched on, the MV sensor and the power sensor. And then the second piece, which is what we call like our back office piece, is our SMS or sensor management system. So it's a server-based application that basically reforms like a central repository for all the data and events that are provided by the two types of sensors we just mentioned. So in addition to providing real-time grid intelligence, an immediate fault and outage detection. The SMS system, it gives you the ability to monitor loads, reduce outages, and also optimize, your grid efficiency. So all that summed into one. These tools that we're going to kind of touch through based on over here on the right-hand side are achieved with the tools of the software. So let's start with like visualization, for example. So from a visualization standpoint, the system, it's a map-based viewing and a grid information organized by substation circuit phase. So when you're the user, you're installing these sensors in the field, you have the ability to use our SMS interface, which is basically a map menu driven system that you can actually control and manipulate where you place the sensors on our software package. So we use a Google Map interface. So you'll actually have a Google Map view on your screen, and you can select with the objects, which we call the sensors, where you're placing them on the feeder. And we actually draw an electrical representation line from sensor to sensor. So you give an idea of, how that circuit is manipulated through your network. So that's all controlled by the user. So the hierarchy would result in, creating yourself regions, substations, circuits, and sensor locations. The SMS also provides custom reports that are available for all the types of events that are captured and reported by those particular sensors. So these reports, like Gary had mentioned earlier, include power off type events, momentaries, faulted, which I'm sure you're all familiar with, line and power disturbances, as well as high current alarms. And these are all coming back in real time. So whenever these events are triggered by the sensor itself, those events are collected and then sent back into the SMS interface. And then we'll manipulate those through our algorithms and then give the user an answer that they could try to understand what's happening on that particular feeder. Now, from an administrative perspective, the software acts similar to that of like an element manager system. If you're used to that, if you have devices out there that you're controlling, whether they're reclosers or cap bank controllers, the SMS acts as an EMS where you can control and manipulate and manage all the maintenance functions or the diagnostic functions, parameter settings, alarm reporting, firmware upgrades. All those kinds of things are done all over the air. So instead of having to roll a truck to manipulate a setting on a sensor per se, you can do that all via your operations center, so that the tech does not have to go out to the field. You're making those parameter changes to either how sensitive you want the sensor to be, to detect certain anomalies or conditions on the line. And also, if we come out with a new firmware package or new firmware upgrade, you can upgrade these things all remotely. So all those things can be done from an administrative standpoint, all over the air, as well as, of course, all the data that's coming back from the interrogation of the sensors. The other two, planning and analytics, we'll touch on over the next couple of slides here. So let's jump to the next one, Gary. Okay, so interval data. So this is an important part. So the grid monitoring sensors, along with the SMS, provide the real-time load monitoring. So the user can quickly plot in graph form the load and voltage intervals, all based on, like I said earlier, user configurable parameters. So you can take these interval parameters down to as low as 5 minutes, and that's how often these sensors will be communicating back to the SMS interface. So that's all coming back to the user in real time, based on what the parameter or configuration setting you have dialed in on the sensor itself. And all of them could be set up for different types of interval reporting periods. So depending on the type of sensor deployed, as we mentioned earlier, some of the key measurements include, load current, voltage, all the power measurements. So you're talking watts, VARs, VAs, fault currents, power factor, phase angles, sags and surges. Another one, conductor temperature, giving you an ambient conductor temperature of the conductor itself. And then also some voltage harmonics with the power sensor. So this data is stored and available historically at any time in the SMS server, which is basically an Oracle. We use an Oracle database. So obviously this is an important feature, to help with identifying troubles that have occurred in the past, and also for any planning purposes that planners might have. It's also important, to remember that, the data that we're collecting, all the historical data that we collect on the SMS server is also available for download at any time via a CSV file format. So this can be brought down by the engineer or technician to create your own customized Excel reports, if you want to do something like that. So all that data is stored historically for the amount of time, inevitably how long you want to actually keep the data, basically. So we'll either, store this in the cloud on a hosted system, or if you decide to bring the system in-house, and we'll talk about reasons for why you'd want to do one versus the other. So the last takeaway important from this slide is Gary had mentioned, touching on how simple and easy it is to integrate any of this sensor data that's coming from the sensors and ultimately through the SMS back to any, complementary back office system such as your SCADA, or, whether you have a PI historian or an OMS system. And this is all done via a DMP3 protocol. So just think of the Aclara SMS acts as a virtual DMP3 gateway to those other back office systems. Very, very simple to integrate with. Okay, go ahead, Gary, next one. Okay, so power quality. So let's touch on some features here. So power quality obviously is a big concern for utilities and can often be a challenge to maintain. So the grid monitoring sensor in conjunction with the SMS can provide, the necessary data to identify these anomalies that can cause certain power quality issues. So the example we see on the top left here of the screen shows a power factor plot, and this is from 3 power sensors we have installed just downstream of a capacitor bank. So in this case, you'll notice that midway through the power factor plot, you'll see the Z phase stop switching with the X and Y phases. So you'll notice the Z phase is the black phase, and the green and blue are the X and Y phases. So it was determined on that point where you see that Z phase stop switching. Obviously, they were able to detect this using the sensors and the power factor data, that there was a blown fuse on that Z leg of that capacitor bank. Now, obviously, this isn't going to cause a severe power quality event per se, but however, using this same power factor data, we're able to identify many times in the past of, flickering light type power quality issue where lights are flickering and they can't quite figure what it is. So using that power factor data, we were able to see some malfunctioning cap controller that were causing short cycling of that cap bank itself. So it was using the same power factor measurements that you can identify these same type anomalies or problems, that therefore causing actual customer interruptions. So it can tie into performance or a power quality type event. So this all ties back to what we had mentioned earlier when Gary talked about the slides of the arcing faults and overloaded transformers. So all of these types of events are causing disturbances that the sensors and SMS can help identify. So typically, like we said, the SCADA system might not, if you have it in place, it might not pick up these minor disturbances that are happening. However, these disturbances to us are extremely important to identifying things that could proactively turn into, anomalies that could be, faults down the road, sustained faults, or even sustained outages. But what it is being able to detect these early signs of disturbances and putting them into some type of rule base, we call it, and I'll get into in a second. It helps the user just keep track of these happenings, and also lets them know that, if we can collect a number or series of these, it could be leading to something that we want to pay attention to before it turns into some catastrophic, fault or outage condition. So go ahead to the next one, Garrett. I lose you? Oh, there you go. Fault detection location. Okay, so this is a really important one for me to go through with you. So based on, using the sensors that are installed, throughout your network, you obviously want to know where faults are occurring, where outages are occurring, and how do I do that? How does the system help me do that without manually driving a truck and having to patrol these lines, manually? So the Aclara grid monitoring system, it uses 2 different ways to detect these types of faults. We use a circuit segmentation method, which obviously you can figure out pretty simply is, if you're installing on a feeder, you have 3 sets of sensors. Obviously, when those sensors are involved in a certain event or a disturbance or an outage condition, we will detect, each one of those sensors will detect if it sees any kind of anomaly on that line, we send that back. So you can then segment where you're going to send the patrol to figure out, where that actual outage or fault is based on did it pass through this sensor location or did it pass through a downstream sensor location? So you'll be able to basically segment that circuit to know exactly where to go based on that information that's coming back from each of those locations into SMS, running it through its algorithms, and then giving the user an answer to say, well, you know, where we think that outage or fault location is. And we also do that with, you know, with the Google Map screen we talked about earlier. If the user is actually, you know, logged into the system, it will actually pop up on the screen the representation of that particular circuit, where the sensors are located electrically on the circuit, and then it will light up that particular location where we decide that the location of fault or outage is, with a like a yellow type push pin or teardrop icon in the Google Map screen. Okay, the second method which we use, which is kind of an important one as well, is our circuit distance to fault estimation. So anytime these sensors on the feeder detect a fault condition, we are recording an RMS fault magnitude. And with that RMS fault magnitude, we take that value, if the utility has this ability to do this, which most seem to have, we're noticing, you take that RMS fault current value and you plug it into a sine model, which is a circuit impedance type model, right? So it's taking that fault current value and using in conjunction with that impedance model, it can give you a representation of different areas where that fault could have occurred. And then you can take that and then use that to tell, you know, dispatch or linemen where they might want to look at based on where that fault current should be on that feeder. So that's actually a big advantage too with the sensors. And we've done a lot of testing with, you know, our fault current values to be very similar to what Schweitzer, who's kind of the leader in those relays and their measurements, to be very close to that, to fit into all these impedance models. Okay, the next one on here is our recurring events. So this one's a critical one, I think, as well. So as we mentioned earlier in the slides, we were talking about all the line disturbances that are coming in from the sensors that other systems might not pick up. So we're taking those line disturbances and it's saying, well, we don't want to become inundated. The user don't want to become flooded with all these line disturbances. What we created this feature, which the users have the ability to pre-configure specific parameters for these types of disturbances. So now the user can create basically their own subset rules for how these disturbances get categorized. So let me take that a step further. So we give the user the abilities in creating these rules that these disturbances have to follow through a certain amount of checkpoints. So in this case, how many times did we get a trigger count from this particular set of sensors on a circuit? So say our trigger count is 5, and then we can also coordinate or calculate the fault current variance in there. So say if the fault current variance is 100 amps, and we want that to be within 10% of 100, we use those 3 categories to pull these into and filter through those disturbances. So the important takeaway from this is, if you have, let's say, a vegetation problem on a circuit where a tree is touching the line, and it's usually giving you the same type fault current within a certain percentage of that, if it's happening repetitively 10 times over within the amount of time you select, say like it's a week type period, well, we'll collect all those disturbances and then give the user one notification of when it meets that criteria of all that data that's in the bucket. So if it happens 10 times, we'll create and collect that data and send the user one notification that we have a reoccurring event at that location. And the important thing here is these are the types of disturbances that lead to permanent outages or permanent faults. So the repetitive, hitting of a line on a circuit or an insulator or a bushing that's, breaking down on a transformer, that repetitive disturbances is ultimately going to cause some serious issues. So if we can collect these and give the user, the bulk of these, that they can go out and look at these, they might be able to prevent that outage or permanent fault and causing the disruption, affecting Katie and affecting, the outage time of the customers. So I think that's a really big takeaway from the system that we get a lot of use from and a lot of feedback on from a lot of utilities. Okay, Gary.
Yeah, that's great. Thanks, Dave. So obviously the software is a key part of turning in all of the data into information that you can then use to make your improve your system reliability. As we've implemented this solution over the last decade plus, obviously case 1 and 2, momentary and permanent outages, those are fairly obvious. But as we've worked with many utilities across the United States and internationally, actually, we've started to bucket some of these applications into cases. And here's 23 cases on the screen, different scenarios that these sensors will help you as the utility. And we've highlighted just a few of them in our last few minutes together. So I'd like to go through case number 9, which is the capacitor bank monitoring. Now, David actually shown this and talked about it on the software, but it becomes fairly obvious where the fuse on a capacitor might blow. So if you're looking at this right here, you can see the failure. Two phases are down here. One's not being switched. How are you supposed to figure out you have a blown fuse on a capacitor out there? How is that going to be possible? Well, these sensors call it out very easily. In fact, we then apply some of this artificial intelligence against these analytics, like I was mentioning. And then when you look up into the event table, it will literally say suspected vegetation, suspected blown, and you'll look like a genius to your utility. You'll be like, hey, boss, I think we got to go do some tree trimming out here before we lose something really important. So this would be an example of application number 9, capacitor bank monitoring. I've picked another one here, large key account customers. So we all have those key accounts. We want to show them a little extra love. And frankly, they are probably the bulk of a potential substation that you have. So you have some feeders, some lines being fed off of a substation, and you might have one of your key customers, which is a significant load on that transformer. You want to give that transformer, that sub, just a little extra love. What we can do is we can take all of those line monitors that you have. So let's say this particular sub has 7 feeders coming out of it, and you put a sensor per phase, ABC phase, 3 per phase, 3 per feeder, 7 feeders, 21 sensors. And what we can do then is we can make a virtual aggregate of that transformer, and we can monitor it and alert and alarm and send you emails and texts off of that. So in this case, everybody's going along just happy until you hit this section right here. This is a threshold you would like to know every time your transformer goes above that particular number. And so we give that sub a little extra love, monitoring it just a little extra. Another case we've called out is application number 20. And this is where you can start to see voltage regulators start to fail due to excessive operations. And so, yeah, we can start to tell when your voltage regulators are about to fail. And so not only can we give you conductor slap during windy days, not only can we do things like vegetation, like we talked earlier, we can also start to talk about when some of your equipment is starting to fail. You can be proactive and get out there before it's a full-on failure. We've even had one of our engineers that's fallen in love with our system, Joel Roper, who's an engineer out of Carroll White in Indiana, distribution engineer. Now he's taken over pretty much almost everything at Carroll White. He's really into the distribution side of things. He took our sensors, installed them on his lines, and there happened to be a cold spell that come through, super chilly. It was an Arctic sort of polar that came in. Joel snapped all kinds of measurements during this cold snap, and then he was able to create a line sag study based on temperature. So we have a lot of people out there with a lot of just distribution engineer geeks that are using these sensors for all kinds of solutions, not just the typical, where is the fault happening. So again, here's 23 cases. The team talked a little bit and focused in on the co-ops and what we thought might be some important ones for you or more applicable, and we highlighted those in yellow. With the last little bit of time we have, we wanted to talk about how to get a hold of us. And so in the slide presentation, of course, we have John with his email, myself, and Dave. John is obviously local. He lives close and will get up and visit you as often as you need. I am with Aclara. I have 5 states. I do have the great prairie state of Illinois. I'm happy to jump on a plane or drive. I live in Michigan over to you. I understand with COVID, you have different rules. Here in Michigan, we have a governor that likes to lock us down and tell us how many people we can talk to. So luckily for me, she's allowing my daughter, who's 16, to live with me. That might change, by the way. I have no idea. I have to look at the news every morning to see what I'm allowed to do. But here's some emails if you have to get in touch with us. And we did want to wrap it up if you had any questions. So just a huge thank you. In this crazy virtual world we have, we appreciate you selecting our presentation to be part of your meeting. And if you don't have any questions, I have some Illinois sort of facts that I'll start to throw out there. So we hopefully we'll get some questions, and I won't have to talk about.
Yeah, before you start throwing facts at us, Gary, we do have a couple questions. So
you got it. Sure, Brian.
First question: will the sensors work on our Wi-Fi network with our VPN?
Yeah, so great question. Thank you. The sensors support a couple different communication paths, cellular and Wi-Fi, and many of the utilities have VPNs and all kinds of security in place. A lot of the utilities are running fiber. They'll drop fiber into an ONT and they'll spark up their own little Wi-Fi that has a lot of the VPN security needed. And the answer is yes. So we do work on your Wi-Fi, whether it's fiber, RJ45. If you want us to create our own Wi-Fi, we can do that as well. We have a little box that you drop anyway, we can create our own Wi-Fi, but many of the utilities are wanting us to jump on theirs, which is fine. We'll even do a little test. So Dave and I have been on site with a sensor and got it up and running prior to prove it, because sometimes your IT teams can get a little crazy with the security, and we want to make sure it works prior to being there. So Brian, yeah, great question, and the answer is yes, and we will test it. We'd be happy to be up on site with all the product and test it prior to purchase.
All right, another question. Can we use our own cellular plan?
Yeah, so continuing on the communication questions, the answer is yes. So we support AT&T and Verizon. Obviously, if you have a T-Mobile, and I mean all those, but mostly people ask us about AT&T and Verizon. And if you would prefer, we could actually provide the cellular plan. We are a Verizon reseller. We brand it under AWN, the Aclara Wireless Network. It's incredibly competitive priced. So it's $10 per sensor per month. That's a direct contract with Aclara, and we give you so much data per month. And if you'd like to go your own path with your own cellular contracts, no problem at all. We'll help you understand the amount of data going through the system so that you can purchase the right data plan as well. So great question, Brian.
Another question that came in, do the sensors require any equipment on the pole?
Yeah, Dave has more experience installing. Dave, did you want to grab this question for us?
Yeah, absolutely. So no, well, I answered that two ways. So we talked earlier about, do they work in a Wi-Fi environment? And Gary had answered that so eloquently, correctly, yes. So what I'll add to that is the only time we would require anything on the pole is if, in this case, like he mentioned, going back to an ONT or a access point. So if that access point, and we're using the Wi-Fi sensors, that access point would, obviously everyone knows, I mean, we're running at 802.11b and G. That access point would roughly have to be, anywhere from 300 feet to, let's say, 500 feet away. So that's really the only time we require physical equipment to be placed on the pole, is if we're using it in a Wi-Fi mode. But other than that, from a cellular standpoint, we don't require anything to be nearby whatsoever. Everything is going back via the cellular network.
Yeah, so and that's if you want us to create the Wi-Fi with our access point, we would put that on your pole. If you provide your own, however you guys do your own Wi-Fi and stuff, that's on the utility. You guys know that better than us. Yeah, good question. But for the most part, no, we aren't around or use the poles at all. We hang the sensors off of your feeders and we're off to the races. Good question.
All right, one last question that came in. Can the sensors detect vegetation and down conductors, and can they report fault current?
Yeah, Dave, why don't you grab this one again?
Yeah, we do. So first part, yes, we do conduct operate in a mode where we can actually identify vegetation. So Gary had mentioned before, based on some signatures and some algorithms we have, we can detect, if it's a vegetation touch versus some other type of interference. So there are specific waveform patterns and anomalies that we know and can use that to detect. And another important part of that is what I mentioned later on in the presentation, using the recurring events is a big bonus to helping us identify vegetation touches, only because typically they're coming with certain patterns and obviously certain signatures of the waveform capture. So I didn't mention earlier, each time we detect any disturbance or fault or outage condition, the sensors are automatically collecting a waveform up to a 14-second sample set. And that's at 28 samples a cycle. So we're pulling that data back each time we collect any type of disturbance or recorded any disturbance. That comes back for the utility to investigate or I guess, dig deeper into what they think the condition can be. And we also have, gobs of experience with, analyzing waveforms to be able to help the utility decipher what specifically is happening out there. And what was the other question was down conductors. Down conductors is a tough one. That's something that's actually on our roadmap. So that's basically what we consider a high impedance fault. Those are a little more challenging to detect. So what we use as a rule of thumb is also try to use, the recurring events to isolate and detect certain anomalies that are happening in conditions like that. So that's how we try to, at this point, tackle that one. That certainly is a tough one to tackle at this point. A lot of sampling goes into that.
Now, Dave, I heard that we're working on being able to differentiate the type of tree lying against the line, oak versus maple. Is there any truth to? No, I'm just kidding. Yeah, we can't do that. No.
Was there another one to that? That was two. Was there a third one?
Brian, was there any other? Did we hit all those when your question?
Yeah, I think you hit them all.
Okay. Good.
And I think that's it for questions. I know if you want to maybe go back a slide and show your contact information one more time, just in case anybody wants to get in touch with you guys.
You bet.
They'd be able to contact you guys, or they could always contact us and we can get them the information as well. So
absolutely. Yeah.
Hey, one thing I'd mention, Gary, if you want to, real quick before we jump off, is just the different aspects of how we can present this system. So whether a hosted environment or a standalone in-house environment. So how simple it is to set these up in the cloud environment.
Yeah, absolutely. So after we say thank you to the AIEC members one more time, get a hold of John Mars if you're interested in pricing. He's got a special webinar price for you guys on a 12-pack. He'll fill you in on any of that. And Brian and Ashley, thank you so much for the opportunity to talk with the team here. We really do appreciate it.
Well, thank you so much, Gary, for joining us today, John and Dave as well. Thank you to everyone who's called in today. Our next webinar will be coming up at 1 o'clock Central Standard Time, Practical Integration of Smart Grid Data. Registration is open until noon. If you miss registration and still want to jump on, shoot me an email. I can get you that information. Again, thank you, gentlemen, so much for taking the time to join us today. We really appreciate it. If anyone needs to get in contact with John, Gary, or Dave, please feel free to reach out to us and we can facilitate that. So, gentlemen, have a wonderful day. Thank you for taking the time.
Thanks.
Thanks,
Be
everybody.
safe out there.
Thank you. Thanks, everybody.